I'm Michael Dufton, I'm the chair of Winchcombe Museum, and I'm delighted to introduce what will be a fascinating story about the Winchcombe Meteorite. This is going to feature contributions from 4 scientists from the Natural History Museum and also the Open University. We are delighted in particular to welcome the Wilcott family, that is Hannah, Rob and Catherine. And this family was the finders of the meteorite on their driveway. So to start, I'm just going to show a few slides which set the scene for this really exciting Zoom session. Now, let's hear from the Wilcott family themselves.
I can't say I sort of expected when I heard that sound on that Sunday evening for it to be a super rare meteorite, but apparently it was. And since then, it's really quite fascinating to see the excitement, not just from the scientists, but also for the town and across the sort of the news coverage as well. But what I would say is that I would love to be able to say that I saw a massive great fireball falling down onto the drive, but alas no, it was kind of on a very still evening. It was a sort of a shattering sound almost, and I got up to look around and couldn't really see anything, to be honest, until the next morning when we were going out for a little morning walk as I usually do before work. And lo and behold, if there wasn't a meteorite on the drive, not that I knew at the time.
Yes, none of us had that idea at all then, because it was looking as though it was perhaps a bit of an upturned barbecue tray. But then we all looked more closely, and it was kind of jet black, not the kind of grey ashes that you get with a barbecue. So we were thinking then that's not quite the same. And you were thinking, weren't you, that it might have been somebody lobbing coals out in the Cotswolds. But because it was at the front door end of the drive, that seemed very unlikely. And it's unlikely in the Cotswolds anyway that kind of thing happens, I hope. Then we started thinking a little bit more, and you got in touch with, you kind of thought, is it space? And is it from space? And
we couldn't imagine where else it had come from, because it was so far up the drive, so it had to have come down from the sky. It didn't look like anything that had fallen off an aeroplane, because it wasn't metallic. And so gradually we started thinking, perhaps it has come down from space. So I put a WhatsApp message out to our family, and our son in Leeds came back almost immediately saying, Dad, have you seen the reports of fireball coming down? So that was when I started looking at the newspaper reports, and I saw that not only was there a fireball, but there was a little map attached to it which showed the likely place where the fireball had ended up was in this area. So at that point, I really started to think this must be something that was connected to the fireball. And I followed the advice that was in the newspapers, I think, which was to collect anything that you found on the ground quickly, put it into a clean plastic bag. So that's exactly what I did. Just went around the garden collecting pieces up. And I reported it to the team who look at the results of cameras which are tracking for fireballs all the time, and they got straight back to me saying that sounds rather interesting. But I think I didn't hear anything more until the Wednesday.
And now I'd like to introduce to you Ashley King from the Natural History Museum, and also following him, Richard Greenwood from the Open University. These are specialists in meteorites, and what they have to say is quite fascinating.
So thanks to Rob and Catherine and Hannah for kicking us off and telling us a little bit about what happened 2-3 weeks ago now. So just to start off, I'm going to do naming things. So hopefully most of you know that we have a solar system. We have a sun at the center of our solar system, and then we have the planets that orbit around. So things like Earth, Mars, Venus. If you go out, you get Jupiter and Saturn. We also have lots of much smaller objects and bodies in our solar system. And these are called comets. And these are the things we often think of being kind of big lumps of ice with a little bit of dust. And sometimes when they come into the inner solar system, they get warmed up a little bit. And some of that ice actually kind of vaporizes, and we get these really spectacular tails of material. So sometimes actually just last year, it was possible to see a comet in the night sky actually for a period last year. And then the other objects we have are what we call asteroids. And these tend to be more rocky objects, and they formed probably a little bit closer to the sun where temperatures were a bit higher. And they're really the leftover building blocks of our solar system. They're all the material that didn't go into making all the planets that we see. And sometimes what happens to these objects, and these things, comets and asteroids, as Michael said, formed kind of 4.6 billion years ago, right at the start of our solar system. So they're older than everything we have here on the Earth. And occasionally, two asteroids will collide together, and they'll knock a small piece off of one of those asteroids. And when that small piece is traveling through space, we call it a meteoroid. And then sometimes, if we're really lucky, that rock will actually come through the Earth's atmosphere, and that's what we call a meteor, or sometimes you'll hear us call it a fireball if it's a really bright event. And then when we're really, really lucky, some of that rock actually makes it down onto the Earth's surface, and we find it, and that's what we call a meteorite. So these meteorites are samples of asteroids in the solar system, and they can tell us about all the different events and all the different processes that have gone on to make our solar system and to make a planet a bit like the Earth. So this is a video. So we've kind of talked about the meteor and fireballs. This is a video taken, and Rob mentioned we have camera networks in the United Kingdom actually dedicated to recording what's going on in our night sky, looking out for these meteors and fireballs as they come in the hope that we might be able to work out where any meteorites may land, and we can work out whereabouts in the solar system they came from. So on the 28th of February, it was about 5 to 10 or 6 minutes to 10 p.m. in the evening. We picked up this video on one of our cameras, and actually lots of cameras in the UK collected this because the skies were really, really clear. And so I went to bed that evening. We thought, well, maybe that could be potentially a meteorite dropping event. We might actually have rocks landing somewhere in the United Kingdom. And so lots of the work that went on that Sunday night was to actually work out, how quickly was this fireball traveling, which direction was it traveling, and if there were meteorites, whereabouts do we think they may have landed? So I'll just play that one more time. So what you're seeing, you get maybe 5 or 6 seconds of a really bright flash as the object's coming in through the upper. This is really high in the atmosphere. And then once that light goes out, these rocks actually then fall down in what we call a dark flight and actually land in an area on the land. And then, and I'll skip through. So these are just a couple more still images. So as I said, we saw the fireball from lots of different angles, from lots of different cameras. So we could work out how bright it was. We could work out roughly, so it was traveling at about 13 kilometers per second. And we knew probably sort of Sunday night, and I woke up Monday morning, we could see things like fragmentation happening. So we were fairly confident that, we probably had meteorites landing somewhere in the United Kingdom. And because we had all the video footage, we could actually work out, and Rob mentioned this, that we could roughly work out what area we thought these meteorites may have landed in. So this is why lots of us went onto the news that day, and we had all these news reports, and we said, if you find any unusual rocks, if you're in the kind of Winchcombe or kind of northeast of Cheltenham type area and around the Cotswolds, please get in touch, because we think there might be some meteorites. And that's exactly what Rob and Catherine and Hannah did. Is, luckily for us, it hit their driveway and they found this material and they saw the news reports and they collected it really, really quickly for us. And so, Richard was over there on Wednesday afternoon, and then he called me and said, I think we've got a meteorite, which was incredibly exciting for me. And so I hopped on a train immediately from London to get over there on the Wednesday evening. And I was really amazed. It must have been 8 o'clock, 9 o'clock at night, I think. We must have spent a few hours sat outside in the cold, but it wasn't cold at all. I think we were so excited just looking at these tiny rocks. And so this is just my final slide before I hand over to Richard, but just because we have the camera networks, we could work out where this material roughly was going to land. But it also means that we could work out whereabouts in our solar system this really special visitor has come from. So on here, you can see that I put in the orbits of Jupiter out here, and Mars is in here, the Earth is in here, and this is the Sun. So we've actually, between the orbits of Mars and Jupiter, we have a thing called the asteroid belt. So this is where most of those asteroids in our solar system that's where they're orbiting around the Sun. And so we calculated really quickly, even on the Monday morning, we knew that this little visitor had come from the outer part of the belt towards Jupiter, was hurtling in towards the Sun. And we're really lucky that the Earth just got in the way. And we're twice as lucky that the Wilcox driveway provided a nice place for it to stop. So I think I'll hand over to you, Richard.
Okay, I'm just going to share my screen. Okay, so Ashley's told you a bit about the what happened on the way in, and that was on the Monday. And I was I'd kept in contact with Ashley, as had a lot of people in the planetary science community in the UK, because we were all so excited about it. And on the Wednesday, Ashley sent over some images and said, look, these are the most promising ones. Can you see if you can get in contact? So I had the fantastic job on Wednesday afternoon of heading up to Winchcombe and to talk to Rob and his family about what they found on their driveway. So what I've done is I've just put up there what we know about the area, and basically the area that we know we've collected material from is between Woodmancote and Winchcombe. Is there more material there? Yeah, absolutely, definitely. We've picked up various bits, enough to define the area to a certain extent, but there's certainly a lot more material, and of course it's spread out across fields and everything. Now, one of the things about meteorites, when they come in, as they break up, is that the bigger bits have got more momentum and they go further. So the big bits tend to be up at the Winchcombe end, lands on Rob and his family's drive, and the smaller bits, which we've already recovered, are down in the Woodmancote area. So we've actually got some small bits from Woodmancote, and we've also recovered some material between the two, which is intermediate in size. So we call that a strewn field, and the strewn field that you can see at the moment is very, if like, ill-defined. We know pretty roughly that's the area that's the best place to look, but you can define the strewn field even better if you get a chance to find us some more material. So just very quickly, Ashley's already told you about the Wednesday and how we came up, and we talked to Hannah, Rob and Catherine, and I mean, it's no exaggeration to say it was literally the most exciting day of my career studying meteorites, without a doubt, because this was such a fantastic meteorite. It's something that's never been found in the UK before in 400 years of looking. So it's incredibly unique, and it's very hard to get that across to people through all this specialist terminology we use. But this is an unbelievable find. So there's the mark in the front there. Is Rob and Catherine standing in front of it, and yours truly on the left, the mark that was made. The second, that's the first. This is the thanks to Rob, these beautiful photographs that he took, what the material looked like when they first came out. Basically, very, very dark, lots and lots of fragments, a lot of dust as the thing disintegrated on impact. So that's the first sample that was recovered so fantastically by Rob. We can't thank him enough for what he's done. It's probably, I would say, probably the most pristine sample that's ever been recovered as a result of a fall. So it's exceptional quality material. We recovered a second sample from Woodmancote. This is what it looks like. It's very small. You can see the ruler there. It's only a couple of centimeters, and that's very much the material that's falling at the Woodmancote end of things. So the big bits near Winchcombe, the small bits near Woodmancote. And I had to actually enhance these photographs to be able to show you any details of it, because they're so black. And that's one of the messages I want to get across to you, is that the material, if you want, is as black as coal. Okay, so these are not representative. I'll show you a couple of images in a minute, which is more representative of what it looks like. Okay, so that was the second bit. And then between Winchcombe and Woodmancote, Dr. Luke Daly and his team from the University of Glasgow who spent 3 days doing really detailed walking out, located this beautiful sample, which I'll go into in a little bit of detail in a minute. And that's kind of like the material that's probably falling in between the two. So we've got other bits as well that have been recovered. We've already got enough so we know the general area in which that they've been collected in, but we know for sure there's a lot more out there. Okay, so what should you look for? Okay, so this is the piece that was found in Woodman Coat. I've enhanced it a bit so we can see the features. So in reality, this stone is much darker than that on the outside. Okay, so when you look at the interior, it looks like coal, okay? And it has these little white flecks in it, which we'll see in a second. As it's coming through the atmosphere, it will heat up and it will melt to a certain extent. So it'll have this on the top, a black, semi-glassy to matte, what we call fusion crust. But if you look at the edge of it, it's very, very thin. So if you find a rock and it goes all the way through, it's not a meteorite. The fusion crust is a very, very less than 1 millimeter thick layer on the outside, and inside it's black. Okay. Sometimes the layer can be slightly orangey, as it's shown there, but not always. So let's have a look at this piece. This is the piece that was found by Dr. Luke Daly, and it's an excellent example of what you might actually see. So it's fully fusion crusted. Okay, so this is this glassy dark layer on the outside, which can vary a lot. So if you look at it at the top, you can see it's very glassy, and it's actually where the stuff was melted and liquid and was coming off the stone. And then if you look down the bottom, you can see it's all cracked up, okay? And it's quite matte, I would say. So slightly glassy to matte is the characteristics of fusion crust of the material that we're collecting in Winchman. Okay. And finally, this is a beautiful image that was collected by was taken by the Natural History Museum. There's a tiny little piece of fusion crust. You can see that orangey color there. The rest is the interior. So there's a couple of things to look at there. So the interior is very black, okay, very fine grained, very black, except for these very, very bright white specks. And those are these high temperature minerals, which tell us so much about and give us the age of the solar system. So the other thing that it doesn't, the important thing is it doesn't have bubbles in it, because one of the things that people pick up is industrial, what we call slag. It's a waste product from industrial formation of mineral metals, okay? And it'll be all bubbly. And the Winchcombe material isn't bubbly at all. So if you think about a very dark, black, featureless material with very bright white flecks in it, and this very thin, shiny crust on the outside, that's what you're looking for. Okay, and this is material that was collected on Rob and family's neighbour. This is one of the pieces that landed on their drive, and that's how it looks. So that's kind of what you're looking for. It's incredibly black. Okay. On the left-hand side, you can see the interior, again, very black, but almost featureless, but with these bright white dots in it, very small. Okay. On the right-hand side, it's the same piece, but rotated. And so you can see that smoothish layer, that's the fusion crust on the outside. It's actually got cracks in it on this one here. It's only at most 1 millimeter thick, so it doesn't go very far, okay? So, and those are really the features that you're looking out for. So very dark, smooth outer, sometimes cracked surface with these very bright white dots inside. So what do you do if you find a sample? You need to follow all the things that Rob followed that morning when he found it on his drive. So don't pick it up with your hands immediately. Don't put a magnet near it because it's got a little bit of remnant magnetization, and that's really important for science. Take a photograph, that's great. And then use something like gloves or foil or paper. Don't use your hands on it, and then put it into a nice clean plastic bag, and then it's safe. And then the final thing is contact us and we'll come and have a look at it for you. So how can you contact us? Well, all you need to do is to contact the UK Fall. Okay, I've left the address there. You just type in UK Fall into Google, you'll get this coming up, or if you type in the full address there, or I use the tag at UK Fireball, and then the page will come up, and at the end of it, there's a little box right at the bottom of the page. It's send us a message, and do exactly that. Send us a message, send us your contact details, so how we get back in contact with you again. include a photograph, that's really helpful. A mobile phone number would be very, very useful as well. So that's it. Thank you very much.
And now it will be really interesting to hear from Helena Bates, who is the curator and specialist again in meteorites at the Natural History Museum, followed by Professor Sarah Russell, who is one of the key figures in the Natural History Museum regarding this entire project.
Hi everyone, my name is Helena. I am the interim meteorite curator at the Natural History Museum, and I've had the lovely experience over the past couple of weeks of curating the Winchcombe meteorites. The main thing that I want to show today is just some pictures, really. So we've all seen this picture a couple of times before. This is the sort of like key piece of the Winchcombe meteorite that everybody kind of recognizes, and it's got that lovely piece of fusion crust right in the middle here. And so this is part of the, we've got about 500 grams, as Ashley said, of the meteorite itself. This is actually quite a small piece. It's only about 5 grams in size. So that's just giving you an indication of its size. I wanted to start by just telling you a little bit about the Natural History Museum collection. Obviously, most of you will probably recognize this building. This is the Natural History Museum. The meteorite collection is located inside this museum itself. We are somewhere in the building. We don't really like to publicize where we are, but we have about 5,000 specimens of meteorites from about 2,000 different individual meteorites themselves. And it's basically one of the oldest and largest collections in the world. So we thought up until recently that our first meteorite specimens were collected or acquired by the museum in 1803, but we actually recently found a record of the first meteorite to be acquired by the museum in 1776. It was a meteorite called Krasnojarsk. So it's basically, Winchcombe being in the museum is also just being a part of the history of the museum itself, which is really exciting for us. The collection itself, it specializes in these meteorite falls, so ones that have been observed to fall, which is what Winchcombe is. And these meteorites are so important for us because they basically preserve some of those extraterrestrial signals and signatures that might be lost when the meteorite just sits around on the ground. So if we can catch them quickly or pick them up quickly, which is what we were able to do with this meteorite, that's ideal. And the museum is really, really, we have a really good collection of meteorite falls. I do also want to say we have, we loan out to international and national researchers around the world. So there might be samples of Winchcombe in America at some point. There might be samples of Winchcombe in Japan at some point. So it's going to go all around the world, which is really exciting. And we're also really excited to work with the Winchcombe Museum and the Cheltenham Museum as well to do some exhibitions and things like that, and potentially even some touring exhibitions around some of the other groups that were involved in collecting the specimen. So now I'm just going to show you a little bit about what my past few weeks have been like, weighing and sorting and looking after these absolutely gorgeous specimens. So on Wednesday, after Richard and Ashley met the Wilcox family and picked up what we're terming the splat material, it was delivered to me at the museum, where I was given bags of the stuff. And so the one thing I really want to highlight here is actually from the material that was recovered initially, there are no large pieces. There are lots of quite small chunks. And so, but that's wonderful for everyone, but it does make my job a little bit more complicated because I have to weigh and store each of these individual stones, and there are basically hundreds of them, which is fun for me. So each individual piece. So I'm just showing you a few images from that initial day of curation. We took out each of these individual pieces and weighed them, and then we stored them appropriately. And I'll show you how we stored them a little bit later. But you can see we've been talking a lot how dark these specimens are, so dark. This particular piece has a few white flecks inside it. These are really exciting little, like some of those exciting little solids that I think Sarah might talk about very briefly when she gets to speak. We have this piece. This piece is beautiful because it shows you that fusion crust really nicely. So this is what Richard was talking about. The sort of outside looks quite shiny, but if you kind of look at it in quite close up, you can see almost these like kind of veins-like structure, like a tree-like structure, and that's because the material has melted and is like flowing. It's really incredible. This is another close-up image of that beautiful, beautiful fusion crust. This is a little example. This is the largest piece that was recovered from the Wilcox Drive. It was 7 grams in size in total. That's the largest individual piece. As I said, I weighed every single one of them, so that was fun. We also recovered quite a lot of dust material from this site. So this is, we poured it all out, weighed the dust, separated the larger fragments, weighed those, but then also stored all the dust as well. Removed the grass and things as well, which is quite important. But we also do, luckily enough, have we have what we call like witness specimens or voucher specimens from the locations where we found the meteorites. So we can, if we find some strange signal in the meteorite, we can look and see, oh, was that present in the soil around where it was found? Things like that. We were lucky enough that Luke Daly and his team from Glasgow found an absolutely gorgeous piece, which Richard showed earlier. Unfortunately, when in transportation, these things happen, rocks break, that's normal. It did break in half. But the great thing about that is we can see inside that beautiful, entirely fusion crusted piece. And you can see here, it's so dark. I think it looks a little bit like a piece of cake, this thing. So I just think, so this is one of the larger specimens that we found. So this was found a little bit later on after we found the pieces on the Wilcox Drive. This is about 50 grams, I think, in total. So this is basically on that first day after I had weighed everything, individually stored and bagged and wrapped in foil and put in vials. I just wanted to show, kind of what we've been doing, how we've been looking after these amazing specimens, treating them with the utmost of care and attention. We then store them in specialized boxes called desiccators. So these are boxes which suck out all of the moisture from the atmosphere and keep it dry and keep it at a constant temperature, constant humidity. All these sorts of things are super duper important. Even more important when we know that, the specimen's only been on Earth for, 12 hours before we collected it. So we want to, make sure we really maintain that extraterrestrial signal. We also took the largest pieces and bagged them up individually in these, what I think look like gift bags, these gift bag containers where so these are the largest pieces. So we're talking the ones that are that large 50 gram piece, and then also some of the smaller 7 gram to 3 gram pieces are all individually bagged in these with oxygen scavengers. So these actually suck out all of the oxygen because the oxygen can cause rust. And rust is terrible for us because, it's destroying some of that extraterrestrial signal. So I wanted to end by, Ashley's already said, we have started on the analysis and we were super lucky enough. I have this picture, you can't tell, but he's very excited, collecting some data from this initial kind of period of curation. What we did with this sample was we were trying to work out what minerals are inside it, basically. So we're putting it in all sorts of instruments and having a look. But yeah, basically that's all I kind of wanted to share today. Lots of fancy pictures of the meteorite itself.
So let me share my screen if I can. So I want to tell you a bit about what we can learn from meteorites, why we're so excited about these very dull looking black rocks. So a meteorite is any space rock that falls naturally to Earth. And as a group, they can tell us all sorts of things about our solar system. So there are a few meteorites that come from the planet Mars, and they're the only samples we have of that planet here on Earth. A few meteorites come from the moon, and they can complement what we already know from the Apollo missions by giving us new lunar material. But the vast majority of meteorites, and dare I say it, the favourites of Richard, Ashley and Helena and me, are ones that come from asteroids, because these tell us about the formation of the solar system, because they date from that time. So the solar system is the sun and everything that orbits it, including all the planets and the minor bodies like asteroids and comets. So at the moment, we're quite familiar with our solar system, how it looks today with these well-formed planets, but it looked very different 4.6 billion years ago when the Winchcombe meteorite was forming. And so we think that there's a lovely circle of life of the galaxy and how stars form and are destroyed. So most of our galaxy is made up of this diffuse material called an interstellar medium, which is made up of tiny little dust grains and bits of dust and gas. And in some places, this interstellar medium can get to be more dense, and then it can start to collapse under its own gravity to form planetary systems. So this is where planetary nurseries are that can form stars and planets around them. So in these dense clouds can collapse around down, and they form disks of material with a young star forming in the center. And then to start off with, it's a dusty disk, which eventually the bits of dust stick to each other and get bigger and bigger and bigger and bigger until eventually you have a planet. And then you reach the stage that we're at now, where we have a star and all these planets around. Eventually, after billions and billions and billions of years, the star runs out of energy and it dies, either explodes as a supernova or it dies as a red giant. But either way, it gives out all of its material back into the interstellar medium, so the whole cycle can start over again. So 4.5 billion years ago, we think the solar system looked something like this. So this is actually an image taken by the ALMA telescope of a star and planet formation, a star that's forming planets possibly around it. So here, the orange is actually dust being imaged. So this telescope is really good at imaging dust-sized particles. This is a picture of the disk of the young star, surrounding the young star, and it has rings around it that are empty. So these are rings that don't have any dust. And we think that's because the dust has grown together to form larger particles, to form asteroids or maybe even planets. At this stage of a star and planet's formation is when the asteroids are formed. So an asteroid is a small body that gets kind of trapped at this stage of evolution. So nothing much happens to it after this dusty disk stage. And that means if we get a sample of asteroids like this, it can really tell us what our solar system was like. So this image is the asteroid Bennu, which has been sampled by a NASA space mission called OSIRIS-REx, and that's going to bring a sample back to Earth in 2023. We already have bits of asteroid on Earth in the form of meteorites like the Winchcombe meteorite, and by looking at them, we've learned such an awful lot about meteorites. So we've learned that they're full of meteorites like Winchcombe are full of organic material that may have seeded life on Earth or provided the raw ingredients for life on Earth. So Ashley's initial experiments that Helena showed a picture of was actually showing that it actually contains loads of water. It contains about 10% water. So that might have provided water to the Earth for it to form oceans. So also looking at the meteorite, it looks very dark black, but it's got white specks in it. And these white specks formed at temperatures hotter than a furnace. So that tells us that as well as having very fragile organic material that never got hot, in the early solar system, there was material around that got super hot. And so it has this mishmash of different objects with different histories, which means that we're going to have to pick it apart, tiny sub-millimeter grain by tiny sub-millimeter grain, and see what each one is telling us about the formation of the solar system, what we can learn about our own origins and about how habitable planets are made. So I just wanted to end up, I mentioned the OSIRIS-REx space mission to asteroid Bennu. There's another space mission that's actually just returned to Earth, which is a Japanese mission called Hayabusa 2. And that sampled a piece of an asteroid called Ryugu, and it returned to Earth in December last year. And when they opened the canister, this is what the sample looked like. So they brought back 4.5 grams of material, so much less than the Winchcombe meteorite. And the tiny grains that were brought back from Ryugu, we think look really similar to the Winchcombe meteorite. So it's really, it's really, really precious stuff that can really tell us so much about our solar system. And it's so important that space agencies go and collect this stuff from asteroids. But having something like the Winchcombe meteorite can help us work with our space mission partners. So we can use Winchcombe, for example, to do rehearsals of analyses that will be done on space mission material. And it will give us a chance to do some very complementary work on this meteorite. So we've got loads and loads of things that we're going to do, and we hope that this can be an ongoing kind of discussion with the Winchcombe people. We would love to kind of keep a dialogue going. As we've mentioned, would really like to keep talking to the schools in Winchcombe and Woodmancote, and work with the museum and make sure that you're all involved. One thing that I think I can say on behalf of all of us is that we've been absolutely overwhelmed with the kindness and generosity of all the local people.
We had a fascinating Q&A session with local schools interacting with the scientists from the Natural History Museum and also the Open University. And out of those, there were 3 questions in particular which seemed to add significantly to the story, and also just showed how interesting it is to get questions from children. So the first question came from Winchcombe Abbey School.
So we estimate that the size of the object that came in through the atmosphere may have been as big as about 100 kilograms of material. But this, you have to imagine, this is going really fast through the atmosphere, and Richard talked about the fusion crust. And actually, most of that rock would have been completely destroyed in the atmosphere. So only a small amount would have landed actually in the area. So originally, when we did the modeling, so we can kind of work out from the videos that we took how much material may have come down. And our original estimates on that Monday morning or Tuesday morning was only about 50 grams. And so then we know that we've got nearly 500 grams of material now, which is much more than we were expecting. So it means that by finding all this material, we can actually try and make our models even better. So the next time this happens, we're better at predicting how much material. So yeah, it's a really good question. I don't know exactly how many stones, but I'm pretty sure there probably are more stones out there in the Woodmancote and the Winchcombe area. Some of them will be very small, I think. But even a very small stone is really important and really exciting for us to study.
And now here are 2 further questions, both from Isbourne Valley School.
Right now, as we speak, we're studying it here at the Natural History Museum, but we also have researchers at the University of Glasgow who are looking at the organic material in there today. Richard at the Open University has been looking at some of the chemistry of the rock. So what's really exciting for us is because the material was collected so quickly and it's so fresh, it hasn't really been exposed to the atmosphere on Earth. That we can learn lots about kind of organic materials and things like water that are locked up within this meteorite that we couldn't normally do for most of our meteorites, because they're kind of contaminated as soon as they reach our atmosphere. And then long term, so at the minute, it's just the meteorite's just sat on the other side from me right now, locked away in a special box, all sealed up, so it's not reacting with the atmosphere. And one of the reasons we do that is so that we can study it now, but we'll be able to study it next year, and we'll be able to study it in 10 years and 20 years. And you know, in 50 years, we'll have all sorts of new science questions and new techniques to study this rock. So one of the ideas behind the kind of curation and storage is that we can do lots of exciting science now, but we can continue doing that for future generations. So if some of you grow up to be scientists, you might get the chance to actually work and study the Winchcombe meteorite.
I mean, I just want to say that I used to work in that establishment where Ashley is, and I studied a meteorite that fell in South Africa in 1838. And it wasn't 1838 when I was studying it, although it feels a bit like that. But yeah, it was preserved in the Natural History Museum and available for study, you know, for well over 100 years afterwards, and it was still a vitally important meteorite. So Winchcombe will be studied for centuries.
We saw it when it came through the atmosphere, and that's why we've built these camera networks. But we didn't actually know that this one was coming. We didn't know it was going to land in Winchcombe at all. So we get probably So somebody described it the other day. So it's about, if you imagine 5 school buses, if you imagine how much that would weigh, that's how much material from space hits us on the Earth every single year. And nearly all of that are really tiny, tiny dust grains like sand, and they just completely vaporize in the atmosphere, so never actually make it down onto the Earth's surface. So it's incredibly rare for rocks to actually land as meteorites on Earth, and we can't predict. They're coming from such small bodies that we can't predict when that's going to happen. But roughly each year we maybe recover sort of 10 to 20 meteorites across the world. So it's really unusual. It doesn't happen very often. It's a really special event. And as Sarah, I think, said, this was the first time for 30 years that we've recovered a meteorite in the United Kingdom. And this is the first time we've ever recovered a meteorite like this in the United Kingdom, which is just doubly exciting.
Well, we've had a wonderful video session here, starting with the story of how the meteorite was found from the Wilcott family, and then an explanation from the leading figures in the UK for meteorite research from the Natural History Museum and Open University. So I'd like to thank all the speakers for their participation and for creating such a wonderful story. And of course, that story doesn't end there. We in the Winchcombe Museum are delighted to say that the Wilcott family have generously donated 3 pieces of the meteorite. We're expecting to receive them sometime this year. And this will be a central part of our new revamped museum. Our project is not only to reconfigure the main museum room itself, but also hopefully to take down the existing ceiling. So we'll have a wonderful atrium space within which to show the meteorite. And we hope you'll help us achieve those dreams as well. So thank you to everybody who's taken part, and we look forward to the next phase of the meteorite story.